Hello, everyone, and welcome to Fragment Tricks. Today we're going to be talking about a few effective patterns for using the Fragment APIs in your apps. Now, some of these are going to be, they may seem a little bit basic, but there are also things that are going to help you build apps in a way that factors your code effectively, encapsulates things, and makes sure that you can keep your code clean.
Stupid fragment tricks.
Yeah.
Stupid fragment tricks.
Anyway, so let's go ahead and start with a little bit of history behind this, which kind of helps to understand where some of the Fragment APIs came from. So as we started moving into large screen devices in the honeycomb era, we started realizing that there are a few specific patterns in the way that some apps are put together, especially apps at the time. You've got one area that's devoted to your navigation, and you've got another area that's devoted to the content. And when you put these two things together, you can imagine on a small screen device, you might see the navigation as one screen that advances to a content screen. And when you're on a larger screen device, you're able to show these same things side by side. So we had this question of how do you write an app that works seamlessly across both? So the Fragment APIs were born. It was something that you could use to factor out your activity components into two separate pieces that you could show differently based on different device configurations. Now, this works really well for some applications like Gmail. But your app probably isn't Gmail. If you've followed the development of app design over the past several years, you realize that this sort of pattern just doesn't fit for a lot of things. However, it's still extremely useful for representing your application as a series of destinations. So even on a small screen device, you might have an app that looks something like this. We've got our little application that, where you can order some micro kitchen snacks around the Google campus. And for each one of these screens, you can perform a replace transaction to replace the destination that you were looking at previously with the new one. A replace transaction will remove any fragment in the container and then add the new fragment. So the nice thing about this is that you can place these particular transactions onto the backstack, and we'll go ahead and handle that back navigation for you. Now, the nice thing about this is that the content and navigation pane separation isn't limited to just large screens. This can really help to keep your Chrome stable in your application. So anytime that you have things like bars, net drawers, bottom navigation bars, any of these things that you want to keep stable and perform some consistent animations from one screen to another, this really lets you do it in a way that is really difficult to accomplish with activity-to-activity transitions, where you can't preserve that kind of continuity in your UI as you navigate deeper in your app's hierarchy.
Let's talk a little bit about navigation flows. Now, when I talk about navigation flows, I'm talking about those step-by-step flows that you have in your application. So when you have a checkout or a sign-up or a setup wizard, you're going to go, the users are going to go step-by-step through their navigation, and then they might want to wander back using the back button, or and then go forward again. And then when they're all done, you want to be all done with that. You don't want to want your user to be able to go back through the checkout process again with the back button. That would kind of suck, wouldn't it? So we're going to here focus on our app, the Micro Kitchen app, which we've been trying to sell to the Googlers to sell them the free Micro Kitchen snacks.
It hasn't been working very well.
It has not. But we know we have new customers coming in this summer, interns. So we're pretty sure that they will partake in our great free Micro Kitchen service. And when the user comes in, they're going to click on the checkout on the cart button. And what we're going to do is we're going to remove the little cart at the bottom, that little fragment there. And then we're also going to remove that replace that big fragment at the top with our new fragment that we're going to label cart. Not the fragment, but we're going to label the state cart. And I'm going to talk about that a little bit later, why we're giving it a name on the backstack. And then when they hit checkout, they can then choose the address they want to ship to, and we're just going to replace that fragment with their address selection one. And they can choose payment then, and we replace it again with a payment fragment. And again, it's added to the backstack. And this time we don't need a name for this backstack state, because we don't need, well, we'll talk about it in a little bit. But they can go back through the backstack if they want. They can navigate back and choose a different address if they want by hitting the back button. And as developers, we don't have to do any other work. Backstack just pops that fragment right back into our state, and it's great. And then the user can go back through, choose the payment, and then confirm the purchase. Now here at the confirm purchase screen, we're going to do a couple things all at once. We're going to do a pop backstack all the way back to that original cart state that we said. And because we passed the inclusive flag there, now it pops that cart state also. And it'll go all the way back, pop all those states back, and then at the same time, we add this new transaction, which will replace that state with our thank you page, because we want to thank them for giving us all their money. It's pretty good. I mean, we need to thank them for giving us all their money. Now on this one, we have a little different thing going on. The OK button doesn't just create a new transaction. It's going to pop the backstack as well. Now, no matter what the user does, the user is going to do the right thing. They're not going to add a new transaction, add to that state. We don't want to have that thank you page come back again if they pop the backstack. So it's going to come right back to where they can buy more stuff from us. So you can see some of the keys here to backstack management. Always maintain your backstack going forward. It's so much easier to manage your backstack if you choose the direction your user is going to go on their backstack as you navigate forward. Don't, at the time the user presses the back button, choose what they're going to do. That's a lot harder to manage. So to take advantage of this kind of thing, sometimes you need to do some synthetic backstack management. That means if you have an external link into your application, some kind of deep nested thing, they're selecting a particular cart item, and when they hit the back button, you don't want them to go to the main screen. You want them to go into the category, perhaps.
Or even from a notification.
Or from a notification. That's a great example from a notification. Or maybe a search inside your application. You might want to have the same thing. So what do? Well, we just execute a whole bunch of transactions all at the same time. Just say, build up the stack for them. Boom, 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 and execute them.
Well, hang on, George. So if I commit repeated transactions, then that means that each one of those transactions, I'm going to start and stop those fragments as I execute each one in turn. So that can be really expensive, right? So how do I go ahead and maintain that backstack state while still not doing a whole lot of really heavyweight work as I start and stop each one of those fragments along the way?
Yeah, that's a really big problem, because you have to create all those views, tear them down again, inflation.
Right, it seems like a lot of unnecessary work.
It is a lot of unnecessary work. Sorry, guys. Well, you want to fix that?
Sure.
All right. Thanks, Adam. So now we have this new thing here called set reordering allowed. And what this does is it allows all of the execution to happen all at once without changing your fragment state. And then at the very end, we bring up all the fragments that need to be brought up and tear down all the fragments that need to be torn down. And now your fragments don't have to go through all that, oh, I got added, I got removed, I got added, I got removed. And so we can optimize this for you. But you have to watch out, because if you expected a fragment to exist that might have been optimized out, if you expected it to go through its creation, it might not have done that. So you have to watch out for this. So you use this in your applications. It's great to use, but expect some slightly different behavior than before. Now, you might have seen in our application that as the user clicked through the checkout screen, it was just pop, 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 pop. The screens changed instantaneously. And that's not very pleasant. So what we can do is we can add transitions. The easiest ones to use are the basic transitions that come with fragments. And there are 3 options. And this is done on the transaction you call set transition. And the basic transitions are fade, open, and close. And from this, it's really hard to see the differences. But you can see the fade has just a simple crossfade. And the open and close also have a fade and zoom. So play with it a little bit, see what works well in your application, see what you like best. It provides a nice, subtle effect for your transitions.
What if I want to do something a little bit more in keeping with my own app's design?
Yeah, if you want something a little more custom, then we can use animations. Animations, in this case, is the view animations that allow you to change scale, rotation, translation, alpha, so fading. So you can set those for, and this is only on the support library. You can set those on the view coming in, the fragment coming in, on a separate one for the fragment being being removed, and also the same things for the pop as well, the ones that are being added and removed. And so you can have different animations for each of those. And you can get an effect like this, which is very nice, a slide effect, which you couldn't do with the basic animations, basic transitions. Now, if you're working with the framework fragments, you can do the same things with animators, but they provide even more benefit because now you can animate any property on the view. It means you can have some really custom animations, whatever you want to do. It's great. And what's better is now you can also do that in the support library. Transition style is also added for the framework so that you can do this, set your animators in a style. Now, a lot of you have been using the activity transitions, and you want to have that work with fragments as well. So activity transitions allows this great ability to have a shared element change from one view to another. So in this case, from one fragment to another. And it works on activity transitions from Lollipop on. It's very useful. And so we added the ability to do that. So in fragments, you call, instead of doing this on the transaction, you do this on the fragment itself. You can set the views, the animation, the transition to do on the views that are coming in. And this is for all the views that are not the shared element. So that's the enter transition. And in the shared element enter transition, this is the one you do on the view that is moving. This is our shared element. In this case, I don't know what it was, the almonds maybe. And here this move views is a combination of change bounds, change transform, and change image transform. There's too many things to fit on the slide, but that's what it is here. And then in the transaction, we add the shared element itself. And the shared element is the view that's in that fragment. And then we have a target name. This name, this is the shared element transition name. And this is the name that you've given the transition element in the fragment that has not been inflated yet. So this, in this case, it's in the my fragment that's being pulled in. And then we can have our transition, which is great. But something's wrong, right? Can you see it? Everyone raise his hand if you can see it. What's the problem with this? Oh, OK. A lot of you can see the problem. Right. Transition's only working one way. Right? It works great getting into the detail view. But when we come back to that main view with all these other elements, you're not seeing it. And why is that? Well, that main view is a recycler view. And what's happening is the recycler view will lay out its views after the set adapter call is made. So we have to wait for the layout call after the set adapter is made. And the transition's coming in and said, hey, I want the shared element. And it's not there. So what does it do? It says, give up, fade out. And so in activity transitions, what do? Well, it's great. We have this thing called postponing the transition. So we have a postpone enter transition. And then when the views are ready, we call start postponed enter transition. So it gives you all the ability to say, OK, just hold on a second. Wait for my views. Come on, views. Come on, views. And then when they're all ready, then you say go. And so we want to do this for fragments as well. So here we go. We can do it for fragments. But there's one extra thing you need to do. You absolutely have to have the set reordering allowed. Because for a short time, while you're postponing, both fragments are there. They're both active. And that is not the order you expect, is it? You expected one to be removed and another one to be added. So both views for both fragments are in the created state. So that's going to be a little weird for you. So we want to make sure that you know that you're getting into this situation. So let's see how it's done in our application. In my onCreate view, now you can do this anytime before onCreate view. So if you wanted to, you could do it in onCreate, whatever you want to do. You call postpone enter transition. Because I know at this point, I am going to do a recycler view. And I know I need to worry about the transitions there. And because I love data binding, some of you might know that. I love data binding. And we have a few models here, too, so that's good, too. Thank you, Adam. If you haven't seen that talk, you should go back and watch it. We're using that. So here I'm setting the adapter for my recycler view. Now I'm setting my adapter. Now I have to wait for the layout. So I'm waiting for the layout. And then that listener, I call start postponed enter transition. Now my transition is ready, and it will just go on ahead. And I think I skipped a slide. Oh, OK. It works.
All right, so one of the other features, moving along to something completely different, one of the other features that we get a lot of questions about are the set retain instance method on fragments. So you retain an instance across an activity, destruction and creation, across something like a configuration change. So this means that the object instance itself of the fragment that you've marked this way is transferred across the parent recreation. So anything that you put there is moved along with it. Full objects. You don't have to serialize this into a parcelable and pass it across as saved instance state. But the important thing to remember if you're doing this is that this doesn't happen if the process is recreated. Your objects aren't there. So you need to be a little bit careful about this. You need to make sure that you can still restore from instance state if you have to, even though in the common case you still have the full objects that you may have created in the first place. So this is a replacement for the old onRetain non-configuration instance method that was on activity. In fact, the same mechanism is used to implement the fragments version of this. But what's a little bit more interesting is that this mechanism is right now the backbone of the new view model component that we've been talking about earlier at I/O here. So the view models are actually saved within a retain instance fragment to shuffle them across from one activity to the next. And this just kind of goes to show the types of infrastructure that you can build on top of a retain instance fragment. It's something that's a little bit on the more abstract end of things. So we end up getting a lot of questions about, hey, what's this good for? Well, this is a pretty good example. And just like we talked about with view models, it means that there's a few things that you really need to avoid. In this case, don't put views in a retain instance fragment unless you want to do a lot of manual bookkeeping. Technically, you can kind of get away with it if you're really careful. Make sure that you release all your references and on destroy view of that particular fragment, so on and so forth. But really, it ends up being best just to kind of avoid it. And we'll get into a few more patterns later in the talk here around what you can do instead. Context, specifically activity contexts. Well, we all know why you don't want to save an instance of an activity longer than the lifetime of that activity itself. But the thing that really tends to catch people is callback references. So if you register a listener or some sort of a callback with a fragment, and that fragment is going to outlive the container, it's really easy to accidentally close over that context that you had and have the activity still outlast the original host. So child fragments are something that bit a lot of people really hard a few years ago because, frankly, we had a lot of bugs around them. And they were created to solve a particular problem, and that was dependency management within a particular activity. So consider this case. You've got a fragment that has a view pager. Pretty common, right? The view pager uses a fragment pager adapter because that's a pretty easy way to use a view pager. And then you remove the pager fragment. Well, now we have a problem. So what actually happens in that case? You've got all the fragments that were added by the pager adapter, but the host fragment, or the conceptual host fragment in this case that has the view pager, itself was removed. Now something has to be in charge of removing the individual page fragments. And this was something that really kind of went to show that a single collection of fragments is insufficient. In fact, when the Fragment APIs were first sort of rolling out to a lot of internal developers right around Honeycomb, this was one of the first questions that we got, and it took us quite a while to come back and address this, of what happens when you do have these dependencies in between fragments. And part of the reason why this was such a pain is because we didn't have any ordering guarantees around fragments being created. And what's worse is a lot of times this only would come up much, much later in the process. Just because you added fragments in one particular order, you could control that order as you're running that and kind of running the initial transactions that builds up that state. But when your process dies and we restore those fragments from instance state later, the order of that recreation was always undefined. Depending on what all may have happened throughout the lifetime of your activity before, just kind of due to some artifacts of internal bookkeeping, this was something that could cause these things to be reordered in terms of which one would get on create first, so on and so forth. And it made it very difficult to reconnect any sorts of shared state. Now, this sort of shared state is something that's much easier to handle with the view model system that we showed earlier. But at the time, we really didn't have a good solution to this problem. So one of the other things that was kind of a pain is that the deferred transaction commits that have been common ever since up until we added the commit now method on fragment transaction. The nice thing and the reason why this was done in the first place was to avoid reentrant calls. You didn't have to worry about one particular transaction being half executed and then starting another transaction as a result of it. But this really did have a cost, and I think that if you're in this room right now, you've probably experienced some of the costs of this. Raise your hand if you called execute pending transactions to fix a bug. Yeah, that's a lot of hands. So this is one of those things that ends up being really kind of difficult to work with. So child fragments as dependencies work out really well because they solve a lot of these particular issues. It's a separate fragment manager, so you don't get the reentrant cases no matter what. If you go ahead and use commit now on a bunch of these things, you don't have to worry about your parent being in a potentially inconsistent state as you do this because you're all working within your own local unit. So all of these things are added and removed as a unit, which means that it solves that view pager problem. It means that if you remove the containing fragment, then you don't have to care about the implementation details of that fragment. Well, this kind of seems like one of those duh things in hindsight. And it's all guaranteed to be restored after a call to super.onCreate. This is also important because now you can rely on when these things have actually been restored. You don't have to worry about these ordering things that are out of your control. But perhaps most importantly, the implementation details, again, don't leak into your surrounding containers. So, in conclusion, many of you may have run into a lot of particular issues around child fragments. Please go try version 26. We have fixed more and more issues around this, specifically around inflating child fragments. This is one of my favorite uses of this. We talked earlier about using fragments as very coarse-grained destinations within your application, something that takes up an entire UI pane of your app. But nesting within other fragments, even if you inflate them from one of these coarser-grained navigation destinations, it just kind of works. Like, you don't have to worry about taking care of all these other sort of nested lifecycle issues. And it lets you build smarter encapsulated components. I mean, we always kind of get this question too. I mean, like, hey, do I build a view group? Do I build a fragment? And there's been a lot of ink spilled and keyboards smashed making these particular arguments online, as I'm sure.
I never know what to do with this. I never know what to do. Building a view group or a fragment?
Right. So
I always tell people, just use view groups.
Exactly. So, excuse me, Adam, you said that crossing the streams was bad. So the rule of thumb for this is essentially as follows. Views should really only be responsible for displaying information and publishing direct user interaction events. These end up being very low-level events, like button was clicked, user scrolled something. These are responsible for drawing text and these other sorts of operations that are user interaction. Whereas fragments integrate with the surrounding lifecycle, and they may be aware of other app components. This is really what gives context to everything that you're doing in your UI. So you might bind to a service. You might be communicating with your app's data model, performing a database query, so on and so forth. So you should never use a fragment when a view will do, but you also want to make sure that you're not adding outside dependencies to your views. It's definitely a code smell if you ever find yourself doing something like trying to bind to a service from a view implementation, or trying to make a network call, or again, trying to integrate with anything that's outside of the realm of just that one individual view. But that means that there's a hole. It means that you can't build just something that's simple as like a completely self-contained like button that you can just stick right in the middle of one of your layouts and treat it as fire and forget. Give it some parameters and go. Well, this is one of the reasons why you can inflate fragments. In this case, we're showing that you can define parameters to these that you can place inline. We can go ahead and inflate arguments in a way that, in a way that allows you to do this without having a lot of very heavyweight integration. You don't have to go find it, configure it separately. You can just do it in line. So one of the things that made this really difficult to do in the past was kind of, again, just an artifact of history, in that you couldn't actually set fragment arguments, that arguments bundle, after the fragment had been added to a fragment manager. So now we've relaxed that, and we've said that now fragment arguments can be changed anytime the state isn't saved, including during inflation. So there's this case where after you rotate or so on and so forth, and we're reconnecting inflated fragments, which is, again, something that we do automatically, then you can run into this case where we've already restored that fragment. We're trying to hook it back up again, but it's already added, which means that you can't do what the natural thing is, which is to represent all those arguments that you may inflate as arguments in the bundle. So that way you have basically a single source of truth for all the configuration parameters of that fragment. Well, now you can.
Wait a second here. Go back.
Go back?
What's this not is state save thing?
Oh, yeah. So again, a bunch of people had, I don't know where this comes from, but people apparently try to commit fragment transactions when state's already been saved, and they've got
Why would they do that?
with this. I don't know, but
Maybe
people
because
say
they can't tell?
that might have been it.
Ah.
Yeah, so we added a simple getter on this one so that you can know when that happens. And it also makes things like writing lifecycle-aware components that make sure that you don't try to commit fragment transactions when it's not valid to do so. Is a whole heck of a lot easier. Thank you. So again, part of what we're trying to do here is create a much better layered infrastructure. We've traditionally hidden a lot of these internals in some of these Android components, such that only the internal components are twiddling them, which means that as soon as you all have a more complicated case that you're trying to handle, we've made it very difficult for you to do this in the past. So we've tried to open a lot more of those things up, make these things a little bit easier to inspect from your own code to deal with those cases that arise that we didn't think of. So in this case, the pattern that we really kind of want to encourage is mapping fragment arguments to attributes for those UI fragments. Again, this gives you kind of a single source of truth. So let's go ahead and go over to an example of this. So in this case, we've got a few kind of nice little Kotlin-based methods that are extensions that make this a little bit easier to handle. In this case, we've got one utility method that is just our with-styled attributes here. So many of you have dealt with inflating attributes for views. And you have to get the typed array, you have to recycle it afterwards. It's real easy to just kind of wrap these up inside some extension functions. Similarly, we have this simple little thing. Hey, is there a bundle there for arguments already? If so, reuse it. Otherwise, create a new one. So these are the sorts of things that Kotlin really adds to the Fragment API. All the things that are kind of a pain in the neck to do with fragments, you can make some simple extensions that were really hard to do before. But for example, one of my favorite features for something like this is to use property delegates to deal with arguments. And you can wrap even more of this stuff and just basically treat them as normal properties on your fragment objects. So putting a bunch of this together, fragments help you maintain more of a content and Chrome separation that give you the ability to keep your content pages as fully encapsulated items without disturbing the rest of the UI around it. You get richer transitions. You get better shared components because you can reuse a lot of these things and you don't have to initialize all of them separately. and you can better encapsulate your dependencies. So you don't necessarily have to leak all of these things to the surrounding host. And thank you very much for coming.